We're going to look at calculating density and put it together with a little bit of significant figure review. Density is an intrinsic physical property of a substance. So, for example, gold's density is 19.3 grams per centimeter cubed, whereas aluminum's density is 2.7 grams per centimeter cubed. The equation for density, you should remember from middle school, is density equals mass over volume. Our units for mass are going to be grams. Our units for volume are going to be either ml or centimeter cubed. They are the same thing. And then the final units are either going to be grams per ml or grams per centimeter cubed, and these represent the same thing. So for short, we're going to say our equation is D equals m over v. We're going to work a couple of examples. We have a 4.8 gram sample of gray metal, and it has a volume of 3.9 centimeter cubed. What is the metal's density? So we have mass equal to 4.8 grams, and we have volume equal to 3.9 centimeters cubed. So we're just going to plug in to our density equation. So density is going to be equal to 4.8 divided by 3.9. We plug this into the calculator, and the calculator says 1.2308. Now, let's think about significant figures. We're going to go to the initial problem. 4.8 has 2 sig figs. 3.9 has 2 sig figs. So our final answer is limited by the weakest value. They both have 2 sig figs, so we're going to be limited to the first two positions. So our answer is going to be approximately 1.2 grams per centimeter cubed. And as always, box your final answer. All right, let's take a look at another one. We have a pine block that measures 2 by 3 by 6 centimeters with a density of 0.5 grams per centimeter cubed. We need to figure out what the mass is. So our volume is going to be 2 times 3 times 6, which is going to be 36. And let's have the correct number of sig figs here. We've got 3 significant figures here, 3 here, 3 here. So we're going to write this down as 36.0 centimeters cubed. Now, our density is equal to 0.50 grams per centimeter cubed. And that's going to have 2 significant figures. We'll keep track of that later. So we're going to write out our equation. We are going to have 0.50 is going to be equal to our mass divided by 36.0. So now we have to solve for mass. So mass is going to be equal to 18 grams. That's what our calculator says. Now, we have 3 significant figures in this value here. We have 2 significant figures here, so we're going to have 2 significant figures, so we would indeed report 18 grams. Example 3, what is the volume of a gold bar with a mass of 2.0 times 10 to the 4th grams? Gold's density is 19.3 grams per centimeter cubed. Let's first take a look at this 2.0 times 10 to the 4th and count the number of sig figs. Remember that the only thing that we look at for significant figures is the coefficient. So this has 2 significant figures. The 19.3 grams per centimeter cubed has 3 significant figures. Our answer is going to be limited to the 2 significant figures because that's the weakest factor. All right, here goes. Let's write down what we have. We have mass is equal to 2.0 times 10 to the 4th. Volume is what we are looking for. And our density is equal to 19.3. So we're going to use the density equals mass over volume. Density is 19.3, and we're going to have 2.0 times 10 to the fourth, and we're going to solve for volume. If you've forgotten how to solve for something in the denominator, take a look at one of my previous videos on how to solve those. After we solve, we're going to find that volume is 1036.26, yada yada yada, from your calculator. But the problem is we're limited to two significant figures. Okay, fine. Let's round this to two significant figures. So the 3 means that this is going to round down. So we go, okay, we've got 1,000. Oh, that's not going to work because this only has one sig fig. We are stuck. And remember, when we are stuck, we are going to use scientific notation. So that is exactly what we are going to do. So let's write this value down in scientific notation. We have 1.03626 yada 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 times 10 to the third. And now we're going to round to the first two positions. This is going to be approximately equal to 1.0 times 10 to the third centimeters